Okay, welcome to lesson 16.1, nature of stationary points. Okay, before we even begin, right, let's discuss what a stationary point is. For example, if you have a graph, okay, that looks something like this, it goes up and come down. Where are the stationary points? Okay, in this case, the stationary points are here and here. A stationary point is also known, either you can call it a stationary point, okay, or you can also call it a turning point. Okay, same for this guy as well. Okay, if you were to draw, okay, or you define the tangent at these points, right, you notice at this point, the turning point, if you were to draw a tangent to the curve there, you'll notice that it will be a flat straight line like this. So in essence, what it means is this: for stationary points or turning points, okay, the gradient at these points, or dy dx, is equals to 0. Right, so that is the first thing that you will learn about stationary points. Okay, without much further ado, okay, what we are going to do is I'm going to do some examples for you. I'll start from exercise 16.1, and the first one I'm going to do is question 1b. First, they give you the equation y equals to 5 minus 6x plus x squared. And the question asks this of you. They say find dy dx and hence find the coordinates of each stationary point. So first I find dy dx equals to negative 6 plus 2x. Okay, from what we have learned above, right, we know that at the stationary point dy dx is equals to 0. So I write there, for stationary point, okay, dy dx equals to 0, so negative 6 plus 2x is equals to 0. And very quickly now we can solve for x. Okay, x will be equals to 3. And to find y, I will substitute x back into my original equation. So y is equals to 5 minus 6 times 3 plus 3 squared. In this case, negative 18, negative 9 plus 5, y equals to negative 4. So the coordinate of my stationary point, okay, is 3, negative 4. And we are done with the very basics of the nature of stationary points. Okay, that is question 1b.